Hi, my name is Lauren Eider. I work for CAS. I'm a chemist by training, and most of my day is spent talking to users of the products that CAS creates on how to best do searching in the scientific literature to look for maybe prior art, what's going on, how they can bring themselves up to speed on the current technology. A lot of times, though, they're trying to make something new, and they're doing prior art searching or novelty searching. And I'm a chemist by training. I wasn't taught how to do prior art or patentability searching, so I've had to learn a lot on the job. And so I wanted to share some of the things I've learned with a broader audience. Because as I talk to the users of our products, and one of the main products that we offer is called SciFinder, oftentimes I ask people if they're doing prior art or novelty searching to explain to me their process. And typically they go in and they're looking to create a new substance for a drug therapeutic, for materials development, for battery technology. They're looking to create a discrete substance, and they want to do a substance search in the registry database because it is the largest repository of known compounds. They want to make sure it's not already been made, which is a great start. And so I invariably come up to the next step. What if you do a substance search in our registry database and you don't find anything? What next? A lot of times, chemists will tell me that usually gives them a very solid indication that there's no substance out there like this. There's nothing already patented because it's not in the registry database. And this happens quite a bit. And I wanted to demonstrate to users why this is particularly, let's say dangerous, but it's misleading to make that assumption. So I'm going to share my screen with you and demonstrate to you sort of the common pitfalls that people make when doing patentability or prior art searching in SciFinder and how to avoid that pitfall. So let's start with the structure drawing. I'm going to draw a structure on here. Make sure this is large enough for you to see. So I'm going to draw something on one of the customers I was talking to a couple weeks ago. Specifically was doing photoresist stray compounds here, and was looking at doing some novelty searching, wanted to patent a particular compound and then sell it or manufacture it rather. So I'm just going to give, this is not the compound he was looking at doing, but I just found similar substances to demonstrate this concept. Bear with me while I draw this structure. So I'm drawing the structure in our CAS draw tool, but you can also use ChemDraw to do this and import the mole file, or if you have ChemDraw 18.2 or more recent, you can directly import that from ChemDraw into SciFinder N. And I'm using SciFinder N, the new tool, our new platform. Just creating those subtle differences. So, and a lot of times when you're doing patentability or novelty searching, you're looking to cast a broad net. So oftentimes people will do a substructure search thinking, well, I want to look for anything, and including variability in here is going to expand that net. So I feel even more confident that nothing exists out there if I do this search and don't find anything. So what I do is a substructure search, and I'm looking at this undefined R group. So my R group, let's say I'm going to look for them purple groups. I'm going to basically expand this out to be a lot of different carbon chains, carbon groups. And then I'm going to add this variable attachment point. Oftentimes when you're doing substructure searching or substitutions on rings, this is a really good tool to use because you can designate any of these attachments and basically look for all these different possibilities at the same time. Using the variable attachment tool and this R group tool to define my variations here. So let's say I want to use that same R group here, do a very similar functionality. Bear with me just a few moments while I create this structure. But oftentimes, like when people are doing novelty searching, they're usually drawing the structure by hand, either in CAS Draw or ChemDraw. And so I'm going to demonstrate the way that this is typically done. So let's say I'm going to create a little bit different substructure here, and then do the same variable attachment here. So, and you don't have to do it for all the ring substitutions. So if I didn't want to have substitution here or here, I would just, I wouldn't have to connect it to it. This is basically saying it can substitute at any of these positions on this ring. So let's look for this substance. So essentially, this is following these steps so far. This is typically what people explain to me that they do when they do a prior art or novelty search to see if the compound that they have conjured or that they want to make already exists. So they're just going to go into a substance search. And there it is. Yep. So looks like if I'm thinking of patenting the substance, I might feel pretty confident right now. There's nothing as I drew it that is similar to this, and there's no substructures that it's given me either. There's some similar structures, but that usually are certain degrees of freedom away from the substance that I'm trying to patent. So this is when I caution people to do a Markush search. And Markush is named after Eugene Markush, who originally proposed this idea of being able to claim certain types of possible structures in a patent. Typically with a patent, you are claiming the substances that you plan to manufacture. But oftentimes, as you guys, as chemists know, you can make analogs that are maybe not as effective as the target compound that you've made in whatever way you're going to apply it, but could potentially infringe on profitability or could be used to make competitor products. For whatever reason, Eugene Markush proposed that he should be able to say, I'm going to capture this field of substances or these categories of chemistries within reason and say that my patent covers not only the target substance that I made, but many of its analogs. And so a Markush structure is one that is captured in the claims of a patent. It may not be the target substance that you see used on the market. It may not be what the manufacturer is actually making, but it does cover an area of chemistry that if somebody else made those materials, they could potentially compete with the product that's patented. And so a lot of people make the mistake of saying, okay, I did a substructure search in SciFinder. I added all sorts of crazy variability. I've cast a really broad net. I get 0 hits. This might be a vote of confidence. They're like, hey, we might be ready to patent this. But before you do that step, just do this one other simple step. This is in SciFinder N. You would go up to this product drawing or the chemistry drawing here. You would basically just simply select do a patent Markush structure search. You should always do this patent Markush structure search in addition to a substructure search if you're trying to look for anything that's been patented. So what is this going to search in? So this searches in CAS's MARPAT database. This is a very distinct database. It's very unique to what CAS provides. It is a database of structures, all the different possible structures that have been claimed or proposed in patents. All the prophetic or hypothetical substances that have been claimed in those patents. As in, when Eugene Markush first published a patent, and he said, all these potential analogs, if they were made, could potentially compete with the product that I'm making or are chemically analogous. So I'm going to claim those, even if I don't intend to manufacture them, simply because it's a competitive move. I don't want people to make competitor products to mine, so I'm saying that that's covered in the patent here. So what the MARPAT database does is it actually captures those proposed prophetic substances. And if those have been proposed or claimed in a patent, it's going to search for that. What's the difference? Just because somebody has proposed a substance in a patent doesn't mean it has a registry number. If it doesn't have a registry number, it's not going to show up in a substructure search in my substance search here in SciFinder N. So that's going to be the difference. So let's see if we do have any patents that show up. So searching all the MARPAT databases, and the more diverse you make your compound, the more variations it's looking for, the longer it's going to take to search through this database. So give it a few minutes or a few seconds, hopefully, and we'll see if we get any results. We do have a patent. We do have a patent here that's covering the substance in one of the variations that I defined. And it's saying it's claimed in the patent claim 1. This is from 2018. So let's see. Basically, it'll also show you any substructures that have been claimed in patents. They're also covered in this patent as well as a few others. And you can see, based on the way that SciFinder N will show you what particular claim is getting hit in response to your query, where it is. So this is in claim 5, this is in claim 1, then it'll show you the structure, or it'll show you the patent rather. So if we use Patent Pack, we can access directly to, we can go directly to the patent viewer. Patent viewer just helps me navigate through the patent. I can navigate to these substances. These are going to be the registered substances that are referenced in the patent. If I want to see the prophetic substances, I have to look at where the claim was. So on this one, it was claim 1. So it's going to show me right here. Oops. This is the substance that gave me a hit. So these R groups here. So I gave it a couple of carbon chain R groups. So you can see these are hitting those variations that I defined. So this is just a general demonstration of how doing a Markush search in addition to a substructure search is going to give you much more accurate results in telling you whether that compound that you have prepared or postulated or plan to develop, whether it's covered in a patent already, and whether those similar structures are already patented as well. We'll go back to our result here. I wanted to demonstrate that to you guys because I see this a lot. It's a very, very common mistake. A lot of people think if I impose some substructure with a lot of variation, I'm casting a really broad net, and it's true, but you're casting a broad net on substances that have already been registered. Now, oftentimes, you might get the very same result. I could have done a Markush search in our MARPAT database, and I would have gotten 0, in which case you could be really, really confident that there's no other substance like that that's been made or claimed in a patent. We always kind of caution that you also need to potentially consult like a legal office if you don't feel comfortable doing this, but we do have over 63 patent authorities that we cover in our databases, which are the vast majority of chemistry information that's disclosed in the public domain. So you can feel fairly confident that if you get a result in SciFinder that has 0 substructure hits on the substructure that you're searching and 0 Markush hits, you feel fairly confident that the substance is novel. But I do highly recommend trying this search before you go any further in your efforts to patent. So that's it for today. Thanks so much for your time. Hopefully that was helpful. And if you have any other questions, please email me at, I'll put this right here. How can I do a search? lider@cas.org. My name is Lauren Eider. Feel free to connect with me on LinkedIn. Take care.